Hi, this video is an overview of what frac sand is and the various health and environmental concerns around it. So what is frac sand? Well, frac sand is used for fracking, or hydraulic fracturing, which is a technique whereby high pressure water is forced into oil and gas bearing rocks to create fissures that then open up and allow the gas or oil to escape. Now to do that, those fissures have to be held open. And so sand is injected into the well to pack into the fissures, but it's a really rounded sand so that the oil and gas can pass through the spaces between the grains. So this is some unprocessed frac sand off to the left, and then to the right processed frac sand, and you can see the grains under a microscope. Very well-rounded quartz grains of an even size of between 20 and 40 micrometers across. So the perfect source of this sand is a really well-weathered old sandstone, like a 500 million year old beach from the Cambrian or Ordovician era. So this is a piece of sandstone bedrock being mined. This bedrock stretches the best bedrock to do this in is in the Midwest. It's this Cambrian and Ordovician former beachfronts, and it stretches in an arc across the upper Midwest, and is from the Mississippi headwaters over to the Great Lakes. And this also forms a giant aquifer system because the sandstone, the permeability of the sandstone that makes it so usable in fracking also makes it excellent at storing water. So this aquifer underlies one of the richest agricultural belts in the world. And now it is being mined because of the fast pace of the fracking industry. And mines are being opened at a rapid pace in places where the sandstone is closest to the surface. This is primarily in the Mississippi River Valley and its tributaries, where the rivers have cut into the sandstone and exposed it to the surface. So there are now 140 different mines. As you can see here in this diagram of a river, the river has cut down through the surface, exposing the multiple layers of sandstone, and in so doing created opportunities for pit mining. There are now 140 different mines, processing facilities, and railroad loadouts in Wisconsin, most built in the past 3 years. And Wisconsin's sand business is booming because the state is situated near transportation infrastructure needed to get gigatons of sand to rail lines that lead east and west to the gas fields of the Dakotas and Pennsylvania, and also to the Mississippi River, where they can head south to the Gulf of Mexico. So besides being big, ugly holes in the ground, what is the problem with frac sand mines? What problems are there? Well, I would contend that the biggest issue is that we don't know how serious all the potential issues are, and the monitoring and health effects have been implemented as an afterthought to rapid expansion of this industry, rather as a rigorous and mandatory part of doing business. So I don't really know how serious a lot of the problems I'm about to describe are, but neither does anyone else really. And with dozens of square miles of open pit mines currently open and operational, and 80 to 90% of the mines in Wisconsin having received non-compliance letters from the Department of Natural Resources in Wisconsin, it seems like something that should be of concern. So the first problem is the scale and intensity of the issue. So traditional aggregate mines for getting sand and gravel for roads and other construction, or even a glass factory for processing glass, are normally small and near their ultimate destination. What distinguishes frac sand is that the mines are much larger. This is about removing square miles of bedrock in a period of just a few years, and this aggregate has very tight constraints on its performance because it has to be permeable for oil and gas. So it needs to get washed, sorted, sifted, and transported to distant wells. So there's far more transportation, and it's far more intensive of a processing stage. So digging into the bedrock, one of the first issues are the water issues. Digging into the bedrock may change groundwater flow to the surrounding farms. Also, the sand has to be washed and sorted, and this takes just tons of water. This is between 700 to 1,300 gallons per minute in a system that's recycling water. If no water recycling is done, this is 2,000 to 3,700 gallons per minute. All water that's pumped from the local aquifer. And there are very often not that many regulations around the pumping itself. Also, chemicals that are used in the recycling of water, such as polyacrylamide, we don't know where these chemicals end up, if they end up in the aquifer, and we don't know if they degrade into carcinogens such as acrylamide in the environment. So that's all an open question, and then after washing, there is frac sand transport by truck and by rail, usually by truck to a transfer facility such as this one in Chippewa Falls, where it is then transferred to trains and railroads. And this can lead to dangerous conditions. Besides the truck traffic danger, there's also burning a lot of diesel fuel, releasing diesel particulates that can cause respiratory issues. And then back at the mining sites and loading facilities, and the sorting facilities, the smallest and largest of the sand particles are filtered out and put back into mounds to be buried again. All of this transport and processing can lead to small amounts of, small or large amounts of silica dust, and these can be released at the mining, transfer, or drilling facilities. So, what's so bad about sand? Silica isn't particularly dangerous in its natural conditions, but because it's actually a fairly large particle. Sand particles that you would encounter at the beach or in soil are not a threat, but under industrial processing and intense pressures such as sandblasting, grinding, mining, the particles can get reduced down below 10 micrometers and even down below 2.5 micrometers. And as the sand drops in size below about 5 to 6 micrometers, it starts to be able to get farther down in the lungs where the body can't clear it out. These small particles are rather sharp, as you can see in this microscope image, which is polarized. So the brightly colored particles are sharp, tiny silica particles. These tiny particles can lodge themselves deep in the lungs, causing silicosis and exacerbating existing issues, existing respiratory health issues. So how would you monitor this silica? Pollution controls for it go back a whole century, and OSHA in the United States as well as NIOSH have actually put out a hazard alert around hydraulic fracturing sites for high levels of silica that are rather dangerous. So whether you're interested in land use planning or problems that large mines cause with heavy truckloads, groundwater, or the quality of life issues around a mine, we would really like to hear from you, Public Lab, and have you join us in helping us with this monitoring effort. So in my follow-up talk, I'll talk about the dust monitoring, which is what we're working on now, and I'd really appreciate your comments, feedback, and support. A lot of people have helped me understand this issue to form this video, and thanks to the 11th Hour Foundation that's funding this. So you can join us at publiclab.org/lists. You can find our air quality list and join researchers who are developing monitoring technologies. You can also look at the tag for silica and follow research notes on the Public Lab site. And again, thanks to all of the sources I used in this video. And so I hope you look forward to my next video, which will be on how we actually monitor silica dust. Thanks.